I'm the president of Monte, New England. And today we have an honor to invite three excellent speakers to talk about merging human and machine perception. So this is just some house cleaning item. This event is recorded, and if you want to chat, you can use the chat function, and we have our agenda over there. If you have any questions, feel free to leave there, and we will leave the Q&A session in the end of the talk. So the speaker won't be interrupted during their speech. So give you a little bit of introduction of what Jade is. We are a group of people enthusiasts about science and technology, and in the New England chapter, we are focused on the biomedical field, and we have done conference like Internet of Medical Things, Precision Medicines, AI in Healthcare. And this year we're moving to online because the COVID situation, and we have done AI in dentistry, how to work out at home topics. You can find those events on our Facebook page, Monte New NE. So this year we have an honor to co-host with Monte West, so we can attract more audience and facilitate more collaboration and bridge together the West and the East. So let us welcome Monte West Chairman David Jang to give us some words.
Great, thank you so much, Hsieh. It's a pleasure to be here today. We're really looking forward to doing this joint event together. We think it's very important that different communities and different groups join together to help build a larger Asian community. Asians here represent a very small % of the US population, and I think it's very important for us to collaborate and work together so we can make ourselves much stronger here. Just to give everyone a little background of Monte Jade. Monte Jade was founded Monte Jade West. Monte Jade West was founded in 1989 by immigrants from Asia. They bonded together to support one another because they were under-networked and under-resourced when they first came to America. Through this community, billions of dollars of enterprise value was created and hundreds of companies were formed. Even to this day, Monte Jade is focused on building community. We do this today under 3 pillars. The first pillar is our interview series, where we focus on celebrating notable community leaders through understanding their personal journey and how they overcame many challenges that they faced. This focus on journey is incredibly important because it better helps connect us from the successful leaders to the next generation of leaders. The second pillar is focused on technology forums, such as this, in which we bring forward to our community new ideas to understand. This enables our members to understand and discover new opportunities for investment, careers, or general understanding. Recently, we have also held different events that discussed AI, investing, biosciences, and communications. Lastly, our third pillar is our most important pillar. It is our mentorship program. This is a 100% volunteer-run program focused on helping build the skill sets of leaders, skill sets needed for future leaders. Eastern Asians in the leadership of many Bay Area technology companies. And today, Asians continue to lag their peers in being promoted. White males are being promoted at 2 times the rate of Asian males, while white females are promoted at 3 times the rate of Asian females. This disparity has gotten worse over the last 2 decades, and our mentorship program strives to address this inequality. This 6-month-long mentorship program focuses on education, deep engagement with small mentor families to help address many of the challenges of moving up the corporate ladder. We've already started our program for this year, our 2020 and 21 programs. As you can see on the slide here, we are backed by many speakers from great companies. From Kleiner Perkins, VMware, HP, Google, etc. Our most recent event was last week on the 22nd, a week and a half ago on the 22nd, and Carol Carpenter, the CMO of VMware, came out and did a dedicated talk for our mentorship program. Can you go to the next slide? Upcoming Monte Jade West, we do over 40 events per year. We have a couple more talks in November on leadership. We have a board-to-board interview series with Hsieh, general partner at Kleiner Perkins, and many more, to name a few. So please go to our website at montejade.org to find out for more events. Next slide, please. We want to take this time to also thank our virtual series sponsors, Deloitte, VenturePack Law, UMC, Silicon Motion, New York Life, and Most. It is with their ongoing support that we're able to run great events like this in conjunction with Monte Jade New England. Normally, when there's no COVID, we also have annual sponsors, and you can see them on the right as well. So we thank them very much for their continued support for our program and what we do, and we look forward to supporting them and our community even more in the future. Back to you, Hsieh.
Thank you, David. Next, we want to invite the TechCo Boston Director General Jonathan Sun to give us a few words.
Thank you. President Hsu of Monte of New England, President Jade of Monte West, ladies and gentlemen, good afternoon. It is a great pleasure for me to attend today's virtual conference. Firstly, on behalf of the Taipei Economic and Cultural Office in Boston, I want to thank the MKNAE and its members for the long-standing support and assistance to our office. In addition, I wanted to know that I consider every one of you an ambassador of Taiwan. By actively making contributions in your respective professional fields, you have successfully helped our friends and colleagues, your friends and colleagues, see how great Taiwan is, what Taiwan has achieved, and what Taiwan has to offer. Today's topic, merging human and machine perception, is actually both interesting and timely. Thanks to the advancement of technology, what was once unthinkable has now become a reality. People still do the thinking, but with the help of machines that can build, store, and compute hundreds and thousands of equations and connections, we have made a jump from big data to deep understanding. The answers to complex questions are coming within reach. There's no doubt that these developments will help improve human lives in all aspects. It will also, however, make the distinction between humans and machines almost imperceptible, which may bring about new problems. Taiwan, being a technological powerhouse and an important player in Industry 4.0, will be able to help on that front. Finally, I look forward to learning from today's discussion and wish all of you great health and success. Thank you.
Thank you, Jonathan. Okay, so our first agenda is on the right in the beginning. And so next, we're going to introduce Tang to talk about using ultrasound as a touch user interface and bring service to life. So let me introduce Hsieh a little bit more. So Hsieh received his bachelor degree in electrical engineering from National Taiwan University, and Hsieh received the Ph.D. degree from University of UC Berkeley. Hsieh's research was focused on ultrasound interface, including ultrasound fingerprint sensor, portable ultrasound imager, and ultrasound gesture recognition. Currently, he is the Chief Technology Officer in the startup he co-founded, Ultrasense System. Tang currently holds more than 10 issued US patents and 20 papers with thousands of citations. He is also the recipient of ISSC C. Lewis Winner Award of Outstanding Paper in 2016 and IEEE MEMS Best Paper Award in 2016. So in addition to the academic excellence, I personally know Tang as a very good gamer as well. He has reached the diamond level of League of Legends, like more than 99 percentile of this world. So without further ado, let's welcome Tang.
Thanks, Hsieh, and I definitely need to add it into next time the short bio. I will be more than happy to talk about the whole presentation about League of Legends. But anyway, can you guys see my screen?
Yes, we can.
Yes.
Okay, so and let's go ahead and start it. First of all, thanks for everybody for listening. And then this is Hsieh. So as Hsieh mentioned, I'm actually working on a company I co-founded. And then we are building some kind of ultrasound sensor on a chip to basically bring the surface to life, which I will explain why is that later. But before I jump into detail, I do want to say about our company actually due to potentially because I literally grabbed a lot of my friends to this company. So this company is almost, I think, 1/3 to 1/4 of the people is from Taiwan. And then we also have actually facilities and also branches on Taiwan, which is actually our second largest branches. In terms of what I view on the hardware engineering perspective, especially silicon engineering, kind of Taiwan is still kind of the best place to go. Like despite our CEO is a Persian guy, but he worked with lots of people in Taiwan for like decades and decades. And kind of proved that for hardware engineering, Taiwan is still I should say almost the best place to go. But let me get started and then try to introduce our company, and hopefully you found this concept enjoyable, and then also have some fun about reading about what we are doing for the past about 2 years. So it all starts with the concept of button. A button is actually the basic method how the human interact with machine. So despite there are more and more inventions try to help human to interact with machine, but as you can see now, keyboard is still in front of you because human is actually already kind of nature to use this kind of like touch feeling or tactile feeling to interact with the world. And people has been striving for using other methods like vocal recognition, speech recognition, for example. And then it turns out I found that even so, there are a lot of inventions from all the big companies. But the vocal and speech recognition is still some kind of minor usage. And mainly the reasons like, and I can share some information when we talk to those companies. Their feedback was like, because a lot of time, humans are too shy. So they still prefer to use a way that doesn't basically affect others to communicate with their machine. So it all come back to, okay, so I still want to use some kind of touch to interact with the machine. So basically I kind of keep my privacy, and then also it's kind of the most natural way to interact with the machine. Okay, but people like button in this way, but people doesn't like button in a few ways. So here is actually lots of history we can talk about it, but this is a great milestone when people are actually moving away from a mechanical button. That's when the iPhones launched in 2007. Before that, it was an age of mostly BlackBerry, this type of traditional phone. And then people want to add more functionality into it, and i.e. more human-machine interface into it. And literally, people try to kill the whole keyboard on the phone and then make the whole phone so bulky. Until the iPhone comes, introduce the technology of touch panel. And then we start to move into actually, I will definitely say the design on the right-hand side will be a lot better and a lot prettier, actually, comparing to the design on the left-hand side. So as you can see now, almost all the phone is benchmarking the right-hand side, and then the phone with keyboard, unfortunately, kind of we don't see anywhere. But it's a journey still ongoing. And then this is, of course, some kind of a things we are working on as like a top, basically the very front line of the technology development. It's like people are not satisfying with I just replace all the button with a touch panel. They also want to remove the side button on the phone, which is the volume up, down key, and the mute key you are looking for. And why is that? When we interact with lots of companies, especially mobile company, there is a very, I would say, interesting perspective is the most important thing for them to replace the mechanical button is the beauty. They want to make their phone look different from others. They want to make the phone completely symmetric. So actually, the appearance of the phone is the thing they actually care the most. And that's also the reason they want to replace the mechanical button, because they don't want to actually have this mechanical button affect their appearance. Well, but there is, of course, a lot more technical reason. Mechanical button actually is pretty expensive, believe it or not. The reason is for the phone, especially, they need to make it waterproof. And waterproof actually costs a lot of materials and also assembly. So the cost to waterproof actually is one thing to keep driving them to remove the mechanical button. Another thing of the mechanical button is it only has one function because it's basically a 0-1 button. While later on you will see our solution can provide a lot more functionality compared to one mechanical button. So that means you can use just one area and one finger to talk to the machine more effectively, because now you don't have only one press function. You can do light tap, you can do heavy press, you can do long hold, and then they all account for different functions. And finally, as we will later on describe outside the mobile and actually to some very basic appliance market, lots of the people are worried about mechanical button is like it's very hard to clean and then it could get stuck. Especially you can think about the appliance in the kitchen. All kinds of methods, all kinds of reasons that drive the mechanical button actually away, despite people still want to have the touch and button detection instead of just talking to the machine. So, and here comes our company. Our solution, as you can see on the very left-hand side, is a tiny chip you see on the finger. And this chip actually contains everything. This chip contains both the sensor and the ASIC. It's actually a monolithic design. Like the whole chip is, the one chip is the whole solution. We place this chip on the back side of any material, and then it can virtually penetrate to almost any thickness on the current design for any kind of consumer electronics. And then it will translate the top side of the stack become a user interface. I will emphasize user interface because it's not only a mechanical button. It can provide a lot more functions on that. Here's a bit company of overview before I jump into the technology perspective. Our company is founded in April 2018. A little bit story here. So my former employer was a company called InvenSense. And this company was like a 1,000 people company. They focus on making the MEMS sensor, and then especially focus on gyroscope sensor. They used to be the world's largest gyroscope supplier when they have basically the POs from Apple. But in Apple, people in industrial, I think lots of people call them poison apple, because if they have you, then you go IPO. If they abandon you, then you crash. But EMSense is not like that bad. It's still, EMSense actually was pretty successful, goes through IPO, and then the company was growing pretty large. But later on in 2018, it got acquired by a company called TDK, which is a Japanese company. And by the time when I was in EMSense, our CEO and our previous EMSense management team, they jumped out, and then also they grabbed me out and then built this company based on some of the research I did back in UC Berkeley. Our office is in San Jose as a headquarters, and we do have sites in Shanghai, Seoul, and Hsinchu. And then with I just mentioned, the Hsinchu is actually the largest. The second largest, and then handle almost all the production facility and production issues. Our investors, especially want to emphasize, our company is backed by a good amount of investors, especially including Bosch and Sony. That's kind of the two most shining names. And then we do have lots of patents going on. There you can search our company's name. You can already found 4 issued US patents. And then there are more to be on. So this is a brief diagram to introduce our technology. So as I just mentioned, our technology is basically a monolithic die. On top of the die, there is a sensor array, and then it's actually made by a piezo layer. And then the sensor array is an ultrasound transducer array. On the bottom of the chip, you have your ASIC to do all the necessary signal processing directly on chip. So the operation looks like this. The chip, on the top of the chip, the sensor array will actively send the ultrasound beam into the stacked material. The beam will hit the top side of the material, and then it will be reflected back, and then collect by the same chip. Depends on whether human finger is touching or not, it will change the reflection. It will change in a variety of ways. It will change not only the pattern of reflection, the amplitude of reflection, And then it actually even changed the phase of a reflection. Our chip, a transducer array, collect all the information back. And then on chip, we do have both analog and digital circuitry. The analog circuitry, of course, taking care of some pre-processing before it enters a digital domain. On the chip, each of our chip contains MCU. That only help you to do the signal processing, but we actually run some algorithm on it. So that means this chip, you can treat it as also a standalone MCU, and then it can be programmed in any form, any way you want to use this mechanical button. So let me use this as an example. Say we do have a user, they want the following. I want the user saying, okay, so I want to use your solution. Give me the following. One tap is basically one type of trigger. Double tap, give me another type of trigger. And then press and hold, give me the third type of trigger with the number of holding time. And then the other customer will say, oh, I am a mobile customer. All I want is a volume up key. You give me the volume up key. So when I press it, it triggers. But I want to adjust the sensitivity of the force you apply. So you can see this is kind of two different applications, but we can support that in the same chip. And because we have some flexibility to program on the chip with the on-chip MCU, and then to support a variety of customers. So this is actually the beauty of our solution is all the way to send from the sensor to ASIC, and then contains algorithm. Everything is integrated in this tiny chip. And then the user, i.e. our customer, only need to insert this chip like this. So apparently this chip needs to sit on some kind of PCB board or flexible PCB board to supply power. But once you supply the power, you only need to use some kind of instant adhesive to attach to some kind of sensor step surface like you want. And then it will start to work. So it's a very simple configuration. And then easy to use is actually especially very important in the sensor world, especially in mobile. Because people always want to have a plug and play solution. And lots of times it's actually not like that. But we offer almost a plug and play solution. Here is our tiny chip. And then this chip contains everything. Stick this chip to wherever you want to make a virtual button interface. And then you're done. And then this kind of easy of lamination and easy of integration actually draw us a lot more attention than what we think at the very beginning because they were suffer from, there are other solutions which contains a lot more integration complexity. Okay, so with that, our sensor now is being used in a variety of domain. For the mobile, we mainly use to replace the volume up-down key. And then there are a customer working with us to implement a selfie button on the back side of the phone. And then, as you know, gaming phone become more and more popular. And people would like to implement two extra buttons on the side of the phone to mimic the joystick. And then this is kind of all the customer in the mobile, they are working on this three direction with us. And then there are other, actually more new technologies being used in this way. We are working with other IoT customer and wearable customer, including smartwatch, and then wireless earbud, and also AR glasses. Those solutions actually, they especially like our solutions because the whole design need to be really small. So they couldn't afford to use a big sensor. They need to use some kind of tiny sensor because they are very limited on the space. But still, you still need some kind of human-machine interface to basically execute the command or talk to the device. So they still need a way to interact with the device. And then they don't even have space like the AR glasses for mechanical button. And that's the reason they come to talk to us. And appliance, I just briefly mentioned on the appliance side, the story is quite different. Appliance, the main reason they like to work with us is they want to make it completely waterproof. And then also enhance a feature by not only a mechanical 0-1 press, but also a different feature, and then they can save a lot of cost actually by not cutting any holes through the stainless steel and directly use our sensor as a touch interface. Okay, a little bit over time, but I want to share a little bit demo video. So this is one of our demo phone, and then I intentionally press it really fast and really low speed to illustrate how sensitive this kind of ultrasound virtual button is. It's under 2mm aluminum stack in a mock-up phone we designed. The color represents the force you apply. And so you can see we actually not only can detect light touch, but also can detect force. And then with limited time, I will show 2 more videos. This is wood. So ultrasound, as I mentioned, like any material is not a lot really alive. You can literally penetrate through almost every material you think about. And then you can see if you touch anywhere outside the material, it's not going to work. You need to touch the location where you laminate our sensor in order for it to trigger. So it's not something like a spring you just attach to the bottom side of the material. Otherwise, your whole material will trigger. Then it's not really categorized as a button. The button needs to trigger only the location when you press it. So I think I will just show one more video on this one. This is kind of the final page I will show, but this is just for fun. Nobody really needs this application, but here is a 2 centimeter of aluminum box. And then the same story, it's not a spring under the metal box. You need to press the button location in order to make it work. But this kind of video kind of shows that there is almost no limit of our technology in terms of material thickness and the material properties. Okay, with that, very much thanks to your attention. And then I will be happy to answer any of your questions later in the panel.
Awesome. Hsieh, thank you. This is awesome technology. I really wish I don't need to clean the keyboard any in the future anymore. Thanks.
Yeah, that's one. Well, that comment really comes from one of our customers.
Awesome. Thank you. So let me introduce our next speaker. Our next speaker is Peter Yu, and he's going to talk about robot perception and tooling for fast and versatile pick and place. Peter received his bachelor degree in computer science from National Jiao Tong University, and he received his computer science master degree in National Taiwan University. He did his Ph.D. at MIT EECS. During his Ph.D., he studied physical contact to improve robots' manipulation skills. His works on robot perception for manipulation are published in top conferences. He's nominated for the best paper finalist in IROS 2016. Designing robots to improve people's life has always been Peter's dream. He worked on perception problems in DARPA challenge, and he also led a team to win the Amazon Robotics challenge in 2015 and 2016 and 2017. After his graduation from MIT, he co-founded XYZ Robotics based in Boston and Shanghai. He now serves as the president and CTO for the company. So with that, let's welcome Peter Yu.
Hello, everyone. Can you hear me and see my slide?
Yep.
Yes.
Okay. Let's see. All right. So I'll continue. Okay, hi everyone. I'm Peter Yu. I'm the president and CTO of XYZ Robotics. So today the topic is about robot perception and tooling for fast and versatile pick and place. Okay, so what we do here is essentially for the robot to pick anything and place anywhere. Yeah. All right. So why do we do this pick and place? I hope everyone are safe and these days due to the COVID, and I believe many people are using the online shopping. or sending packages around. So after you do the online shopping, there are actually millions of workers behind the scene to get your goods picked in Amazon warehouse, or after they pick your item and ship it, they go to a distribution center like UPS or FedEx. They have lots of people doing this conveyor belt induction. So in the challenges in logistics is like rising labor costs and high turnover rate. And there are human will make mistakes because sometimes it's a sorting process, and human after 8 hours of standing work, it will be very tired. So that's what we are trying to do, trying to automate the pick and place. In logistics, it's called piece picking, pick things one by one. So here I'll show you a video that's how our system work. This is called 1 to 4, from 1 tote to 4 totes. Oh, okay, one tote to 4 totes. So usually this tote coming in is homogeneous items, like the same item. And here we have a tool change that can swap to different size of cups, so that suction cups. And then they can help to pick up many different kinds of items, including some challenging reflected items. And here it shows the toppling. And here it shows the gentle placing. Okay, I hope this gives you a quick overview of what we are doing. So there are some key metrics for automating piece picking. There are rate, how fast you can do. Usually the customer will like the robot to perform as fast as what human, or even exceed human. And range is like the different weight, different size, and different material of the item that the robot needs to be picked up and placed. And reliability, unlike lab work, which only doing it for demo or for video shooting, here we really want the robot to work like 24/7 without much human intervention. And there is cost, because it's kind of like replacing a labor, and you want to have a good price, because the robot system is also kind of expensive, so we need to reduce the cost so that it makes sense to replace the human. So okay, so our solution is there's one key thing called our 3D AI vision processor, and then that's kind of the eyes of the robot. And then there's hand of the robot, which is the XYZ tooling component. And by combining these, we form turnkey solutions. Okay, so let's start with the vision system. So the vision system, the key thing is it's model free. What it means is the robot doesn't learn the individual items. It actually learns kind of a geometric primitive, so that if it's a box or a bottle, it knows where to do the picking. Okay, and these yellow spots are where the vision system predicts the picking points. And it's pretty fast, 0.1 second for VGA mode. This is important for achieving the rate that the customer wants. So this is like random pile, and this is tightly packed items. Sometimes the tightly packed items are even more challenged than random situation, because it's hard to discover the seam between two items. So if you pick at here, it's very likely to double pick, and that creates problems for the warehouse. So we can pick a very wide variety of skills. So again, we don't train on individual of them. We kind of let the human instill the picking capability to the robot by doing labeling and some training to the robot, so that in the end, the robot know how to pick it up and human doesn't need to do it. So on the other hand is the tooling, and tooling means what was attached to the robot. And this is our typical end of arm tooling attached to the robot. Here's a key feature of compliance. So it's like when it hits the item, if it hits the item, it will automatically retract passively. So it won't collide with the item or damage the item. Okay, and then there's a tool changer. So the tool changer is something like this that help you to swap between different suction cup or even a gripper. So I will claim that as far as we know, we have the fastest tool changer in the world. It's 0.5 seconds per change. Okay, so here I would like to show you a video of what's going on for the tool changing. So here is the tool changing dock. Here we have the suction cup and the gripper. So typically we like to use suction cup, but there are items that's say thin or mesh items, which you really need the gripper to grab the item. Yeah, so it's very low profile. It's not big, so it can get into a clutter scenario pretty easily. So something like this bath sponge or this tool need to use the gripper. Okay, so what we want to say is for the robot to increase the range, it really needs to use the right tool and for the right job. And here we have the mechanical capability here. And on the software AI side, we also need to give the robot the intelligence of knowing which object we should use which tool. Okay, and here is a close look of a gripper that we develop in-house. It's a soft gripper, and it will help like picking items and not damaging items. And sometimes there will be a unexpected collision, and the soft gripper is good at adapting to the scenario. Okay, and it's the design of it is driven by vacuum, so it can easily swap between the vacuum and the suction cup, just using the same tubing that we have. Okay, so here I will show you many other scenarios that we have deployed. The first one is palletizing, depalletizing, which is a larger scale, and it's a real hard need because usually these boxes are pretty heavy. Yeah, and on the second one is picking Legos. Lego is pretty challenging to pick because it's irregular shape. But we are able to develop our tooling and the vision system to pick it.
Chosen candidate. This is what's happened now, and nobody's ever seen anything like it. Everybody knows that it's incredible. Nobody's seen anything like it. You don't read anything. You go to the Times, you go to the Washington.
Okay.
Can we, beside the speaker, can we mute our microphone? Thank you.
All right. So, all right. Here is an interesting one that's inside a warehouse where they sell the only cell phones. So the robot need to be placing it flat so that it can be feeding into this packaging station that's downstream. So you placing, the robot can put it flat. Like here, it needs to do a toppling motion so that it lays flat and get adjusted and feed into the packaging station. Okay, so this one we have seen it. I will say, let's see this one. So this is a so-called rebin station that's in the warehouse after a batch picking. So there are non-homogeneous items, like meaning different types of items here. And then it's doing a barcode scanning while it's doing the picking. After picking, it knows where to place in the different copies in the shelf. So then each individual bins here on the shelf will go into a specific customer. Okay, and then on the right is again, this is palletizing. So the first one is kind of a depalletizing. This is after manufacturing. All these needs to be shipped to customers, so it needs to be palletized in order to get shipped out. Ooh. All right, so a bit about the company profile. We founded in 2018, and we are in Series A+. And how we come into this, how the technology come here is, while I was in MIT, my lab participated in the Amazon Robotics Challenge for 3 years, and we got top 3 performance in all 3 years. And our headquarters is in Shanghai, and I'm currently mostly in Boston office. And then we have about 80 employees from top engineering schools in US and China, and also from industry. So overall, we want to transform the logistics and industrial automation using AI and robotics. So here are some ideas that I would like to share. Sometimes at the beginning, our core is the vision algorithm, but we later find out, like, even though we can see where to grab, but if the physical gripper is not good, it cannot grab it. So later we go on to a kind of a more full stack approach, meaning hardware, the tooling, and the software, vision system, and AI need to be co-developed in order to achieve the rate and range and reliability that we want. And then in our world, the physical construction is expensive. As you see, the robot is huge. All the peripheral things are huge. And if there is something wrong that doesn't fit, it's quite expensive to change anything. So something that we want trying to go virtual, like something like we build a cell in the virtual world and try to simulate it, make sure that works, meet the criteria before we go build it. And then go remote is like sending a maintenance person or anybody to the site is pretty also expensive. Those sites are usually in rural area. Okay, so then trying to do maintenance remotely, say the robot, when it's doing the picking, it uploads the data to a server, and so that the server can do some training and update in order, and then send it back to the individual robot to update its capability. And on the other hand, if the robot really have some trouble at the time, it can send a request to a human remote helper. That's what we call. And then the person can help, like say, click on which point to grab, and then the robot can execute. And then there's almost zero downtime there. And there's some sort of minimalism that we want to impose on our system design. Something like the tooling, like we are doing it in a very minimal way. There are people who put different gripper, different suction cups on the same tool. That's usually prone to break. That's a lessons learned from the competition. And we really need to be robust and for the real deployment. And in the end, I do robotics, and I kind of see it as a way to bridge the virtual and real world. The virtual means the computation world, which I came from, and the real world is some sort of the more mechanical world. That's where like physical item exists. And so I think in the past we have done a lot of things in the virtual world or perceive things in the world, but robotics really do action in the real world to change it. And kind of myself and the company is trying to use the robotics to increase human productivity. All right, so that's the end of my talk. Yeah, I think we can discuss more during the panel. Thank you.
Thank you, Peter. This is great technology. Like, it helps us staying at home during the COVID time. Really, really great help from this technology. Okay, I'm going to hand over the microphone to Leon Chen. Leon Chen is our Monte president, Monte New England president of 2019, and he's going to be the moderator for the rest of the seminar.
Hello, hey guys, can you hear my voice? Hello.
Great.
Okay, cool. All right. So with two of the great company here we saw merging the human and computer perception, of course, all of the new technology need, money to actually introduce the innovation, right? So our next speaker, Dr. Peter Hsieh, is coming from a venture capitalist angle. So Dr. Hsieh currently is the general partner of Acorn Pacific Ventures, graduated from Stanford, Ph.D. in ultrasound and optics. Dr. Hsieh has more than 20 years of experience in venture capital, which includes 10 years in Silicon Valley and another 10 plus years in the APAC area. So in the VC space, starting from the Silicon Valley, Dr. Hsieh was the partner of Harbinger Ventures, as well as the senior associate with the Investar Capital. And as for the Asian Pacific experience, Dr. Hsieh also was the partner with Asia Fest Partner, which is located in Beijing, and also the president of Cotronic Venture Capital. But venture capital is not the sole thing that Dr. Hsieh does. She also have substantial and very rich amount of corporation experience, including being the chief strategy officer for Cotronic Corporation and the president of Optoma Corp, which is also fall under the umbrella of Cotronic. Some of the successful IPO experience for Dr. Hsieh includes OmniVision, Uplink, Apply Optoelectronic Inc., and iSoft Stone. So these are the companies that went IPO, and also there are some of them for M&A as well, including Ultima Interconnect, later got merged into Cadence, and U-System later was merged into the GE Medical. So throughout this wonderful career, Dr. Hsieh created an overall value over $8 billion US dollars. And outside of the working space, Dr. Hsieh is also very active in nonprofit. He's the current vice president and vice chairman of the Jade Science and Technology Association located in Silicon Valley. So without further ado, let's welcome Dr. Peter Hsieh.
Thank you. Okay, what you see is a PowerPoint. It's not. How do I do slide under this?
Yeah, this is great. We're seeing the slide.
You're seeing the slide, right? Okay,
Yes.
great.
Mm-hmm.
So thank you, everyone. I just want to say how grateful and honored I am to be able to speak at this venue. I am actually a son-in-law of the New Haven area. And the reason is my wife, she's also a Taiwanese and actually got her master's degree from University of New Haven and in healthcare management. So that's a wonderful experience to come back to here. And I miss all the lobsters I can have over there. Yeah. Today's topic took me a while to understand, and I decided to approach it from a different angle. The topic is merging human-machine perception, rather than saying it's merging human-machine interface. So when I was writing the speech yesterday, human-machine interface market currently is worldwide is around $6 billion. And its growth is only about 8% to 10% a year over the next several years. So from a VC's perspective, and especially there are so many people tackling human-machine interface, $5 to $6 billion with so many startup companies is actually a little bit too small. So I looked at the topic again and found out the event host here in our friends in New England decided to call the topic as merging human-machine perception. So perception is definitely different from interface. I did some further research and found out this. A brief about Acorn Pacific. We are a venture capital firm with a lot of executive and venture capital experience, both here in Silicon Valley, Taiwan, and Greater China. We started somewhere in 1999 with a bunch of very, very successful Taiwanese entrepreneurs here in Silicon Valley. Companies they have either founded or invested, cumulative, if you add the number together, exceeds about $200 billion. So it's quite a legacy from the old Acorn campus area. One thing I think in the East Coast you also have is Ranch 99, which is also created by several of the founders of Acorn previously. Acorn Pacific continues the legacy of Acorn Campus, so we're the new generation. Myself, our chairman has already introduced myself, so I'll skip this slide. This one talks a little bit about how people see it, and this is a very old slide that you can see everywhere. To the left is human, to the right is machine. And the horizontal arrows in between is the interaction and the interface. But what I think the topic today is related to perception, which is on the human side on the upper lower corner, cognition, how people perceive and understand. On the right-hand side is how the machine utilizes the data to understand. Hold on. On the upper right side is called processing. So interface, it's easier to be quantified, but cognition and processing is a lot of gray zone. For example, if a girl approaches one of you or a boy approaches you for your telephone number, how would you perceive that? Is it that he is interested in asking you out for a date, or he mainly wants to have a professional acquaintance, or he just wants to add you on his Rolodex? These perceptions are very, very different, and people can understand, and machine can also understand it differently. Therefore, when we enter the world of human-machine perception, the market size is much, much larger. I hope I can get that idea across to you guys. Using Chinese perspective, when we say 五官, it's 眼耳口鼻心, and plus there's also 皮肤, which is haptic response. And you translate that in English, it becomes eye, ear, mouth, nose, mind, and touch. If you look at the right-hand side, it actually corresponds more or less to optical, acoustic, bionic, tactile, and motion. Now, motion is related to touch. We previously had a company who was presenting a pick and place type of robotics with very advanced grips. But in a lot of factory automation cases, you do not want your robotics arm to swing too fast because there may be operators nearby. So having some kind of tactile feeling is also important. Knowing that there are something nearby and the machine, the robotic arm should stop is also important. On the actuator side, these are interfaces I'm talking about. We have fingers, vocal cord, you speak to people, you sing. You also have limbs, which is your robotics arm, and others. Maybe it's your tongue, your smell, and everything else. So 眼耳口鼻心 plus 皮肤, that actually stands for a lot of the human-machine interface we want to talk about. And but the most important thing and difficult thing is the machine processing and human cognition. Now, I say this topic is a very superficial venture capitalist speech is because we want to talk about processing, but your speaker today here is a VC who has not been an engineer for over 20 years. And also the computer language I'm capable of writing is only Fortran 77, not even C++ or whatever. So bear with me. It's very, very ancient feeling here. But I want to share with you why I care less at the end of this talk, because if you enter a board meeting in any startups in Silicon Valley, to be honest, the biggest topic is not technology of the company. The biggest topic is the business of the company. So now, I understand from the pre-meeting preparation that audiences of this event is not only engineers, also there may be some architects, some economists, some accountants, and other people like myself who know nothing. So briefly, artificial intelligence is the main set. A subset of that is machine learning, and the smaller set of that is deep learning. Very, very briefly, the concept is AI is the broad discipline of creating intelligent machines by using logic. Machine learning refers to systems that can learn from past experience or past data that has already been collected. And deep learning refers to systems that learn from experience on large data sets, also able to collect data from sensors. So we have these human-machine interface that's collecting data. Therefore, if you have a deep learning model, it continuously learns by being provided with more data. Therefore, when we talk about all of these things, I want to focus on what deep learning is related to. Application for all of these, we can see on the left-hand side, we have automotive. You can all feel this Tesla, chemical, petrol, mechanical. For example, I spent 2 summers also near New England in Connecticut, a small town called Ridgefield with Schlumberger Dow Research. Is a petrol company. I did a lot of ultrasound related study and also wrote several papers during my 2 summers of intern at New England. That's related to petrochemical. It is ultrasound and a lot of software process behind that. Mining, paper, food, healthcare. People talk about a lot about healthcare here. Oil and gas, entertainment, which is important these days. Education, which is also a hot topic after COVID becomes a reality surrounding us all here. But on the right-hand side, VCs, of course, care about which vertical industry you are in. We also care about the market, the user scenario, especially most importantly, it's not the ROI. In this case, it's not the ROI for the VC itself. Sometimes it's the ROI for the business we want to evaluate, meaning is it going to be able to generate true value for its customers? Usually I would say if you cut into two segments in startups, one is in the B2B space, the other is in the B2C space. B2C spending is more discretionary. If you buy something from Indiegogo and spend $200, and if the product is not delivered, it's okay, because you know sometimes you will not get that money back. But if you are a purchasing manager over there at Apple, and you decided to buy some technology or some product from a startup, it must be something that's very, very critical. So when we look at business, you have B2C and B2B. B2C is easier to have initial revenue, but B2B companies takes a long time. Usually, even after 24 months of founding of the company, they still do not have a customer, not even mentioning to have a proof of concept contract signed. Technology is important. Regulation. A lot of people will say, oh, we have all these autonomous vehicle technology available now. But the difficulty is the regulation and the insurance. Who is going to pay for an accident if your Tesla gets into gets in an accident? Privacy. I'm coaching several companies that are related to the AI space right now. Being able to continuously learn from the massive data they are collecting into the cloud. In fact, there's still a lot of regulation difficulty, and these consortiums such as IEEE has not come up with anything that all companies want to warmly welcome. So privacy is ongoingly going to be a problem. For example, our robotics company, you learn something from one company A, but how do you make sure company A's learning gets also to be used with company B, right? There are a lot of tricks here, and we are still in the early stage. People, it is very, very important, because networking and also having a team of people working together. So I really admire our Ultrasense founder, being a Taiwanese and working with a lot of people in very coming from very different backgrounds. It is a great thing to have. Ecosystem, of course, is important. From my limited perspective, capital investment is also important. The next slide. So now that I have painted the background, that I don't only want to talk about interface, I want to talk about the perception and cognition. This slide talks about AI and ML, machine learning VC deal activity. I have to move this small window somewhere else. As you can see, last year, 2019, actually, dollar amount started decreasing. We are just having too many investments in the AI and machine learning industry. But this is not a bad thing, because this means that the first wave of hype is actually getting rid of a lot of other companies, or companies that does not have enough good value proposition to get them out of this competition. 2020, of course, this is just a first half number. So you can see the investment dollar amount exceeds $40 billion, or somewhere around $40 billion in 2019. And in 2018, it was somewhere around $50 billion. These are huge numbers. Comparing this with the HMI interface market, which is only $4 to $6 billion. So it's one order of magnitude difference. This slide talks about region. Of course, North America and Asia. And on the left is investment dollar. On the right is investment deals. Very quickly. And this one has one interesting company that we're all familiar with. It's on the news every day. The number one company is called ByteDance, right? The company in China, which has received, as of June 30th of this year, $6 billion US. So if you look at these top 10 companies and look at the country column, which is the second from the right, you can tell a lot of them are related to consumer. A lot of them are related to software or platform, and most of them are based out of China. This is a slide that generally talks about AI and ML ecosystem, where we are focused. We initially in today's talk focusing on is on the lower left, AI and ML semiconductors. So ultrasound sensor, I would categorize you as a semiconductor sensor. Intelligent sensors on the lower, on the middle, in the bottom. But if you go to upper left, you see computer vision and automation platform. If you move further to the right on the top, you see autonomous machines. And then going down from autonomous machines, you see consumer, IT, industrial AI, and even moving to the right, you can see the application in healthcare and transportation. Now, this is just a very quick snapshot of how one research analyst paints the ecosystem or the market for AI and ML. And the interface part is just a small part of it, but the one that uses cognition and also processing is actually taking up a huge proportion of the whole space. This one talks about VC-backed vertical application companies. Again, Kuaishou and ByteDance are one of the top ones. They have each raised $6 or $4 billion, and they're also listing some incumbents down there. This slide talks about platform companies. All I'm trying to show here is that everyone understands just focusing on the hardware part, on the interface part is not enough. It's the processing of how you understand the data and make it useful and make meaning out of it that is more important. So what I want to deliver here, the important message is enabling technology is always out there. For example, on ultrasound sensor, I've seen at least 5 companies using them to do touch, to do button, to do something else. It's the real implementation that is critical. So the enabling technology is only just a small piece of success of a startup company. So what I say here is that in a lot of cases, it's not the key factor for success. While other aspects such as market, you want the market you're addressing to be huge, the people networking, because you don't want to only work with a small bunch of people. You want to have a proper go-to-market strategy. You want to be able to get out of, for example, the Massachusetts area or Connecticut area. You want to branch out into Silicon Valley. You want to go to Asia. It's the people, it's the network, and also in your hiring and also in your fundraising. Co-investor is also very important. On board meeting, I can't stress more than enough. Especially during COVID, I would say at least a third or 50% of our board meeting time is spent on talking about who is the co-investor of our company, who can we invite into our company so that we can weather through this very strange time of COVID-19. Business model is very important. I'm talking in this case, thinking of a lot of the audiences have engineering background. A revelation I had starting 2 years ago was, yes, technology is important because technology has a lot of zeros and ones. It's a lot of logic. But business model is also very critically important because business model, if you properly design it, it also has a lot of logic, meaning 0 to 1 behind it. So properly design a business model as to, for example, when do you want to hire the next critical person in PR? When do you want to get out of US? Do you want to go South America? Do you want to go Southeast Asia? You want to go to China, or you want to go to Europe? It's all different decisions. And these are all logic that you need to somehow quantify. Speed of execution is also very, very important. A lot of very successful entrepreneurs here or overseas that I have observed, they are actually very good at execution. If you think too much, again, I'm contradicting myself about business logic, but sometimes you just have to give it a try. Just like in software development, you have this MVP type of concept. Fundraising capability, I would say, is number 1 always, because you can see all these companies that are raising billions of dollars. It is critically important. These factors, other than technology, I want to share with my fellow Monte Jade members over there on the East Coast are also important, not just focus on technology. Thank you. This ends my talk today. Thank you.
Thank you. What a great insight from Peter Hsieh. So let's dive into our panel discussion then. And I notice we have some questions from the participants. So let's do this. I have some of the pocket questions, which I will start first. And then when I exhaust my short list of questions, we'll go ahead and have Hsieh collect the question from the chat room, shall we? Okay, so my first question is, since Peter Hsieh also talked about the impact to business in this very strange time of COVID-19, I wanna broaden this question to everyone. So let's start with Hsieh. How did the COVID-19 impact your business? And does it accelerate it? Does it change it? Does it shift it in different ways for your ultrasound technology?
Okay, so let me also share. It's almost like a realm of gossip, but put it in two ways. On the funding side and customer side. On the funding side, we are actually getting kind of lucky. We finished our last round of funding this year, January, right at the right time. So we didn't get impacted too much by on the funding side due to COVID, but we do hear a lot from our VCs. Is basically the funding literally just like kind of stop, and then lots of investors here basically they are kind of sitting here and then see who can survive this COVID situation. So I have actually also a bunch of friends working in startup company at this moment. They want to also raise another round of funding, but lots of them fail. It's a tough time for funding raising for sure. On the customer side, also our business side, actually there is apparently a negative impact, especially in our industry, because sensor company actually rely a lot on mobile customers, and then mobile customers, a lot of them are actually in China. So when COVID started, actually the whole China shut down. And then we have a good amount of program basically just paused. And then we literally have some program which is like, there's a key project engineer, and then they go back to Wuhan for Chinese New Year. So literally have this kind of thing happen. So it pushed out, of course, a lot of project by, I would say, at least 3 months. So that's what we have seen due to like this COVID condition. But now, at this moment now, I think people are kind of getting used to it, getting settled, especially on the Asia side. So, and then our customer mostly is in Asia. So it's kind of recovering as part of what I see. It's not as bad as what we had before on March and April when there's literally lots of project paused. But it's paused, not cancel. Fortunately, it's paused. So just like basically delay. You need to kind of strengthen your pocket and make more runways to kind of survive through this time. And then looking for probably a goal of next year. That's kind of what we are seeing, and the approach a few startup company has been doing so far.
Cool, I see. Thank you. It's a very hard time to raise fund at this very unpredictable moment. What about Peter? Do you see any difference in the way your business turned out to be in this COVID-19 period?
Mm-hmm. So actually, logistics is kind of an essential business. So we count ourselves as essential business. So we try to keep operating, but with some precautions on like sanitizing, all those stuff. Yeah. So actually, for existing customer, they keep they are also essential business. So we are still keep on doing things, trying to do things remotely, or if we need to travel, we just drive over there. So it's kind of more hardcore, I would say. And so yeah, on the business, on the need side, I would say it's actually will increase overall, but the operation is harder for us because the robots, it's a physical thing. We have to have the person to come in and operate it. I would say, yeah, just harder on the operation. And during the Chinese shutdown, and we kind of our supplier who does the machining also stopped. But right now they came back. That's great. And actually, it's now the U.S. going back. Yeah, so overall challenging, but it's fine. And on the funding, I think we are pretty lucky. We got some funding I forgot, it should be in summertime, June, July. I forgot when exactly. But yeah, I do heard here it's challenging to get funding to that side.
Cool. I see. What about Peter Hsieh? Does the funding side really decrease in this COVID-19 period from your perspective?
Let's go back several years, just not just mentioning COVID, because the whole international funding cycle is different now. If you look at before end of 2017, there were a lot of money coming from China to come here to the United States to invest. Starting from December of 2017, they had RMB control, foreign currency control, so that it's hard to convert that into US dollars. And so that made a lot of Chinese GPs here, whose LPs come from China, suddenly they have a fund and have commitment, but the money cannot be invested here. That's just due to Chinese government's regulation. And subsequently, I think people vividly remember there was a Chinese fund, private equity fund, wanted to acquire Philips Lumenlight here in the United States. And also, I think is it Cypress or something, semiconductor here. These are all big deals that they were trying to do. Because at the time, I felt it was reasonable, because if people are criticizing stealing of IP, then I would just buy the company, then I would own the IP. So that's okay, right? But very quickly, US government started implementing these CFIUS type of rules. Now, CFIUS, I don't know how to describe that in English, but in Chinese, it's like a 尚方宝剑. It's all subject to their human interpretation as to whether you are doing something that's against US national security. Therefore, suddenly a lot of semiconductor companies, both that used to be doing business on both sides, or anything that's related to AI that's doing business on both sides, started having to pick sides. And this situation, of course, has not stopped. But I want to emphasize, this does not mean startup activity or funding or capital market over there in Asia has stopped anywhere. For example, we have one portfolio company who licensed one of their technology into a Chinese subsidiary. They merged with another entity over there, and recently is about to go public in Hong Kong. And our shares are 100 times oversubscribed, which is huge, right? Meaning there's still a lot of money there trying to chase after deals. So yes, the world is getting polarized. But over there on Asia Pacific or within China, there has been over the past 2 decades a lot of capabilities stored there, energy stored there that are waiting there. So it's just temporary, I would say. The second topic is related to COVID on the from the VC perspective. Of course, we venture capitalists, I can claim myself as a very experienced person, having weathered through several ups and down turns. But this time is so different. It used to be I can still see people. Now I get to see you people only on my 27-inch screen. I can no longer shake your hand to feel whether you're sweating on your palm. And you cannot see me after our meeting, whether I am sending you off to the gate, to the elevator, or I'm just sitting at the conference table and just say, hey, thank you, nice meeting you. These are all very different gestures that we cannot observe. And previously, I would go to the parking lot to see whether they have a lot of Teslas. Nowadays, I don't get to see that to see whether these people are living near a luxurious lifestyle. So we are losing a lot of parameters and factors that we're used to judge people, and vice versa for entrepreneurs to judge these VCs. But hey, we are still collecting management fees. We still need to do our investment. So we are forced to continue to talk to companies. But yes, initially it is very slow. But recently we have decided, hey, we still need to gear up our activity. So I'd say VC activity in all of these is a low pass filter. Whether the quality will be there or not is going to be very different, because when I say networking is important, the way of networking is something that we have never been able to see, but we're more efficient. If you look at, for example, your App Store download or the update for your app on your cell phone, every day there are 10 or 20 of these that get updated. That means in some area, people are getting more productive. So I would say we're adjusting to a new norm. It's never going to be the same, at least in the foreseeable future. Thank you. Yeah.
Thank you. Yes. So definitely, if you're fundraising, drive a Honda Fit instead of Tesla.
Of course.
Yes.
And don't bring a tune into the office.
Of course, yes. So the more of the story. Okay. Which leads me to my next question. So on the next series of questions, I will be asking for what will the future looks like for the two different technology we have here. And eventually we'll move that to Peter Hsieh, because he's a venture capitalist. He will have his perspective so we can validate if the sort of technology point of view actually is slightly different from the VC point of view. So why don't we get started from Hsieh? What do you think the future of the sensoring and button technology will look like? Who will win in the foreseeable future?
So maybe in general sensors. So actually before when I as I typed in the chat, before I worked on this company, I also worked on ultrasound fingerprint sensor. It's a great amount of my career has been like playing with sensors and playing with especially mobile customers. And you can see in my talk, I keep mentioning mobile customers. Because when we, as a sensor company, mobile customers kind of your bread and butter, and again, poison apple, because that's, mobile is the one, actually the one market which can bring you tons of revenue. Like example is like every like a top three mobile customer, they ship like more than 100 million phones per year. So you get into one model, maybe only 1 million or 10 million, but you immediately get this kind of revenue. And then as a sensor company working with mobile people, and I just described the reason why we need to work with mobile people due to the amount and also the revenue. What we have been seeing so far is like the key to work with them is actually not really technology driven. It will be very interesting. The one is usually it's like actually it's kind of aligned to what Peter Hsieh is talking about. Usually now mobile, they have lots of application driven. It's basically driven back from the application side. Usually it's like, let me give an example. I just mentioned the selfie button. It's like they come up with the product design of, okay, so now I want to enhance. And then there is actually some example I couldn't talk about. But a mobile customer, they are trying to invent a lot from the application side. And then those applications drive their need for a virtual button. Because it's like, I invent a new idea, and then this is totally software related, by the way. It's basically totally driven by the software and then apps. But in order to use this feature, I need some way to, as a user, to enter the function. Okay, so I want to create a button, but because this is a special function, I want to make it cool. I don't want to make it the same location as a volume key. So I put on the backside of the phone. And then they talk to us. And then enable this feature. So it's actually very app-based driven, I need to say. So in this case, I actually think a lot. Need to say a lot to my in my company. One of our co-founder is he is already like a 30 years experience selling sensors, and he knows a lot of like big guys in like especially Chinese mobile customers. And then of course you first get information, so this kind of like relationship and personal channel. Like they are going to march on this, and then you can provide a more solution actually better fit for it. So it's kind of like this kind of cycle. Instead of usually what we saw also a lot of companies say, I have a super cool technology, let me go to sell to a customer, and usually it doesn't work because it's more like customer they have something in mind, and then you enable them, and that's kind of how in the sensor company is selling a new sensor that we can sell. And finally, just another key point, and very not a small key point, but a short key point. Another winning factor is like whoever support a customer the best usually will win, because sensor is to be honest is not a big portion of the whole phone. Maybe it's enabler for some of the key features they want to enable, but mobile customer what they are looking for is always a plug and play solution. So whoever provides them the cleanest and smallest solution usually will win. it's not even about the technology or price. Like usually they are willing to even pay a little bit more extra fees if they have a solution easier to be implemented. So that's my perspective. Thank you.
Thank you. What about Peter? Do you think of any future winners will look like in your robotic segment here?
Okay. Also, we are talking robotics, right?
Yep.
Okay. So in terms of robotics, again, I talked about this physical construction that takes time and money. So how to make sure it scale? I think that's important. And one aspect of it is creating some sort of easy interface for how like human can or the operator can command or teach the robot how like what to do. So what's the challenge? Say like robot is working in 3D space. Like there's not only XYZ but also row pitch yaw. So that's kind of different from say operating iPhone, which is almost a 2D space. So something like that, how to make sure that sort of command can be sent correctly to the robot. And yeah, creating the UI is important because there's always some customization needed for different sites. And in behind this robotics, there are many different fields of knowledge, the mechanical, electrical, software. All those are in its own very, very challenging. So how do you make sure a normal person, like usually warehouse operator, and a worker can understand and configure in a way that they want is a key step to scale. Okay, so right now there are a lot of work from the integrators, like system integrators. Lots of manual hours to design it, lots of manual hours to test it, and also talk to customers on what they want. Usually the customer even don't know what they want. They kind of know they want to take in place, but they don't know, say today, what's the voltage they can provide, and say there's a conveyor coming in, conveyor going out, like that. And also think about the safety issue, which we are currently also dealing with. Okay, so yeah, so my first point is on the interface. And what the winner will be is a lot depends on getting an application, making sure it works. Okay, so that's kind of what system integrators do. So, and that means kind of meeting what customer needs. And Peter Hsieh brought up like having the kind of a cobots that focus on safety. Yeah, there are some situations that the operator wants to use that kind of robot doing in a safe way, but most of the time slow. Like we actually have a customer that they want this kind of cobots to start with because they want the safety. They don't want the cages. But later on, when they find out the price, the cobot is actually more expensive. It's slower if you really want to guarantee safety. Like say right now we can use industrial robot to pick 1,000 pieces per hour. Using the cobot at the safety speed, we probably can only pick 100. So so if you really look at the charts, the cobot still have a struggle to dominate the space, although it's really a more advanced technology. Yeah. All right. So these are my views.
Thank you. So from what I heard, I think, Peter, you were talking about scalability. You're talking about interface, who has the best interface, and also you're talking about how to navigate through the actual problem, the actual pain point of the customer, because sometimes customer themselves does not know what their pain points are. So with those perspective, let's bring it to Peter Hsieh. Hsieh, Peter, do you think of these? Do you agree? First of all, do you agree with these perspective?
I absolutely agree. That's when Peter, you talked about changing cost structure when you want to have haptic feedback. It is so critical. New technology may be fancy, interesting, and good, but when you talk about real world money, especially in the B2B world, people care about that, right? Yeah. So I remember for another. That's one aspect. The other aspect is. For example, even when I was in college, Hsieh and me were joking yesterday. I saw his Gmail to be B94, right? Yeah. So that's how we our Hsieh in National Taiwan University was. And I told him I was B71. So I cannot imagine when I graduated, Hsieh was not even born. So it's a very interesting perspective. But what I want to see is even when I was in NTU undergrad, we talked a lot about MEMS application. MEMS was there already. And at the time, the textbook was teaching us its accelerometer, its tire pressure sensor. And throughout that until year 2000, so I was in school in the early 80s, right? In year 2000, suddenly MEMS has a new application, which is a lot of people are thinking about using MEMS to do switch for networking. So, and I also saw another UC Berkeley graduate and who was a UCLA professor was using MEMS to do fingerprint sensor at the time. That was year 2000. And then all these companies that are trying to use MEMS to create network switches, not too many of them are left, which means that was a big wave, a lot of money being poured in, but turned out it was not good enough, competitive enough to other types of technology, in this case, semiconductor. So I would say scalability, and in English we say there's so many different ways to skin a cat. So to achieve one particular application, you will have multiple different technologies that can achieve that. But at the end of the day, for buyers to decide, number one, they want to look at cost. Number two, they want to look at ecosystem. For example, are you the only person that can supply this type of technology in the world? In that case, that's going to be difficult. I definitely do not want to do that because it's going to be expensive. And sometimes, maybe one day your company gets acquired by another competitor, then I have no longer access to your technology. Case in point is, for example, Intel acquired the FPGA company last year, and now AMD is acquiring the only one remain, right? Intel acquired Altera, and AMD is acquiring Xilinx. So when we look at all these things, one thing I learned in the English word is you want to take a holistic view rather than just one single narrow vision. And in a lot of cases, this will help a person to make a lot of decisions. A lot of us are technologists here. So to me today, F equals MA and B equal to IR are the same thing. So just want to bring this perspective to my fellow friends over there on the East Coast. Thank you.
Thank you, Peter. So being holistic is really outweighs being specific on each and every category, but you want to have lack of saying, but it's like a feeling, right? It's more of a feeling that you have the potential to compete with all the potential competitors.
Yeah, yes, so, of course, of that, but you need to carve out a way for your own niche. But these two things come hand in hand. Thank you. Yeah.
Thank you. Which I want to extend on this question too. So can you share, which is for Peter Hsieh, can you share a story where you have a winning investment and compare it to maybe the one that didn't, the company that you invest that did not go so well? Can you share some of those stories?
We VCs always will talk about our winning investments and deals that we passed but we will never talk about deals that we invested, but that we lost money. That's not how we operate.
Okay, so can you share a winning story then in your previous experience?
Yes. One deal that when I went to China, and the reason I went to China was because I'm more of a hardware person, not a software person. You know, I only write Fortran 77. So I went to China trying to do a lot of fundamental engineering, manufacturing related deals. But it turned out at the time, to be honest, China was doing a lot of manufacturing, but not a lot of low-level technology, the fundamental technology related things. So I looked at a company who was introduced by a friend out of Stanford GSB, Graduate School of Business, and look at the outsourcing field. At the time, Infosys and Tata Group out of India were all growing at 30% a year and enjoy a PE ratio on the public market of 30%. So was a good business. And China, salary of people at the time was very low. That was back in year 2004. So I looked at the company, and later on, it became my model in China. The entrepreneur himself grew up in China, but has been in the United States, not only as a student, but also a professional for 10 years, over 10 years, and have gone back to China for over 10 years. This means we can communicate using Western ways of transparency, but if the CEO is required to drink baijiu when he wants to entertain his customer, he can still do that. So this is 海归加土鳖 together. You want to have the best of both, and a person needs to do that in a very natural manner. So I backed the CEO this and also invited him to acquire another company. We have been able to grow the company since my original investment. I think it was 600 people. And today the company has more than 60,000 people. It's the company called iSoftStone. I've also lost a lot of deals, which is, for example, Peter Yu, I think one of the deals that I missed is your customer. If I look at the video and guess correctly, I'm not sure whether they are. It's 365 or JD.com. Yeah. So back in year 2007, I looked at the company. Gross margin was only 4%. So this is a narrow vision, engineer's perspective. I said, 4%, the heck, it's never going to be possible that you're going to make money. So I challenged the CEO how he is able to increase his gross margin from 4% up to 15%. And that's when Amazon started making money. CEO, of course, did not satisfy me for the single vision on gross margin only. So I passed on the deal. That was in year 2007. It turned out I was right. The company did not become profitable until 10 years later, 2017. So I was right on passing the deal because the company could not make money. But on the other hand, I missed the bigger picture, which is China is such a great market, and there has to be another Amazon-like company over there, or a variation. So given my knowledge or experience now, I would have said that, okay, look at what connection the CEO has, what other co-investors are looking at that, and I'll do a club deal with other co-investors so that we make sure this is the best company out of China. So there are a lot of these deals I miss in China because I'm a foreigner over there, and I didn't quite understand the deal over there. But one other thing I wanted to bring to my fellows here is that compared to Silicon Valley, salary over there in Taiwan is about a quarter of that in Silicon Valley. So you still have a bunch of people with very good technology and works very hard there. So try to set up some offshore operation there, and they can, on the one hand, help you do business in Asia, but on the other hand, it can save your company a lot of burn in cash. Thank you.
Thank you, Peter. Very, very precise insight there. So we are running a little bit late, but I have two questions actually from the audience. So let me iterate them. So the first one is a question to XYZ Robotics. What is the user interface that you think is the key important feature for your customer? So I think this is for Peter Yu.
Okay, I think just a quick answer is like during the calibration, like during the setup time, we usually need to do the calibration of the camera, calibration of where's the toad, calibration of where's the tool changer. So all those things are added to the setup time. So in some way, there could be a automatic way of doing all those that will help the setup time. Yeah, setup is the human labor time equals the money. And sometimes more fancier command is like picking up, and they want to place it in a certain pose, say during the packaging. So how do you teach? Say long way should be in this direction along a conveyor or a slot. So those things are, I would say, higher level and not easy to say without programming so far. But yeah, that's where we want to a breakthrough so that a lay person can do that. Yeah.
Okay, thank you. Hopefully that answered the question. And I have another one, but this is the last one because due to we're running late. So I believe this is a question for Hsieh. So the question is, how does the ultrasound chip solution compare with other non-mechanical approaches such as capacitance sensing? For example, can ultrasound being applied to iPhone for touch screen sensing?
Okay, actually, type some brief answer in the chat window. But lots of people asking us about like capacity versus our solution. So our solution does indeed can work under glass. So people does ask for to use our solution as a touch panel. But need to say usually this is not kind of our top priority. And then also be very frankly speaking. Capacitive touch has been developed for a very, very long time. And then that also means the cost will be extremely low because it has been developed for a long time. So if you have this kind of condition, then it will be a very hard sell. Also, we can do the same thing. So as you can see, when we first pitch our product, where we pitch on the side of the mid frame. The reason is capacitive couldn't work under metal by principle because it's using the electrical field. So and then another thing capacitive couldn't do is that capacitive usually couldn't work with a very thick stack. A thick stack means for example 2 millimeter of plastic. It's not even conductive, but it couldn't work on the plastic. And the third thing is capacitive actually couldn't measure force. And then so you can see why we picked this kind of a side button because it needs to be under metal. And then you need to measure some kind of force. You don't want your volume key just trigger when you just touch it, right? So you need to kind of measure some kind of force. So you need to find a kind of region where capacity just completely out of the picture. So this is a main difference on the technology side. And so that's also the reason why we go for the side button, but we don't directly compete with capacitive touch panel on the screen. Finally, on top of that, the touchscreen industrial is already so well developed that it's already integrated as a part of the display. So this is actually another reason you don't want to go to this route because it's already there's a two big company, they collaborate, even merge together, and then they provide customer a solution of here's a touch plus display. How do you even penetrate this market, right? So that's will be my 2 cents about using our chip as a solution as a touch. In short, it can be done, but we choose not to do that.
Thank you. I see. So let's wrap it up. So I will give our time back to Hsieh then.
Thank you everyone for thank you all the speakers for giving the great talk and sharing your great knowledge. And thank you Monte West for co-hosting this event. And right now I'm pasting a link of a Google survey form. Like feel free to tell us how do you think this event is and give us some comments. How can we do better in the future? And let's want to give the mic to David to talk about his following events for Monte West.
Great. Thank you very much. It's been a pleasure doing this event jointly with Monte Jade New England. I'm very happy again that we're able to do this partnership. And I really, truly believe that, it is through this collaboration that we as a community can become stronger. I want to also thank all of the speakers that came out today, Peter and Hsieh as well, for coming out and joining us on a beautiful Saturday day in the West Coast. I really appreciate your ongoing support for our community and the events as well. Just as a reminder, we have a couple of events coming up. We have 3 already slated for November. So we have a leadership event with Teresa Stevens and Kim Marsalis. We have a board-to-board interview series with Hsieh, who's a general partner at Klein and Perkins. We also have another one with Guang Li, who's the managing director at TransLink Capital. We have events in December, also in January already. We're actually booked out all the way to July of next year already. So our calendar is pretty full. So please go to montejade.org to find out more about our events coming down the line. And lastly, I want to just thank our sponsors again. Thank you for all the work that you guys do to allow us to do our work. Venture Pacific Law, UMC, Silicon Motion, New York Life, and most. Thank you very much for continuing to believe in us despite the craziness in COVID. I wish to thank everyone for coming today, and back to you, Hsieh.
Yeah, thank you everyone. Hope you see you in the future. And please follow us on Monte NE at Facebook. I'll paste the link on the chat room.
Great. Thank you guys. Have a great weekend.
Great weekend.
Thank you.
Thank you.
You guys.